So now I'm going to start this section on tangent and derivatives. This is an important section because this is a section in which we introduce you to the concept of derivative. First of all, let's try to understand what a tangent is. You see this curve, right? So what kind of curve is that? It's a circle, right? So we have a circle here. And you can see that this line is drawn in such a way that actually it touches the circle exactly in one point, and that it is perpendicular to the radius of the circle. So this type of a line is called a tangent line. So this line, which is denoted by L, is a line which is tangent to the circle at this particular point P. So when you say a tangent line, we have to tell the point, right? And we must make sure that line actually touches the curve only at that point. So when we have a function, keep putting it very briefly, when you have a function and if we have a point, right, and if we have a tangent line at that point, so you take the slope of this tangent line, then we say that slope to be the derivative of this function at this point. At this point means the x value of this point. So whatever is a point, then at this particular x value of the point, the slope of the tangent is called the derivative. We'll come back to that a little later. But let's try to understand some myths about tangent line. Now look at this first graph. We have a curve, we have a point, and we have a line. But is this line a tangent line? Well, the line crosses only at one point, but the line does not really touch at one point. It crosses the curve at that point. So crossing is actually not being tangent. Tangent means you have to touch it at that point. Now here is an interesting situation. If you look at this line L, it is tangent to this curve at a certain point. At what point? At P it is tangent to the curve. So the curve is there and the line is there. P is there. Can you see at the point P it is actually touching the curve? So it's tangent to the curve at P, but it is not really tangent to the curve at this point right here as well as this point. It crosses the curve at two other points. So tangent line can actually cross the curve at other points. There's nothing to stop that from doing that, but at least at the particular point that we're concerned, it must not cross but only touch. So the third situation is actually, here we have a curve and the tangent line actually touches the curve, but like in this side the tangent line lies on one side of the curve, but here it lies on two sides of the curve, but still it's okay because it only touches at one point. Can you see the idea of the touch? Okay, very good. So that's about tangent lines. So now let's take a look at a dynamic approach to a tangent line. So how does a tangent line happen? Well, let's try to see whether we can create the tangent line at the point P. So what's our purpose? This is our curve. Okay, this is our curve and we have a point P and we are interested in getting a tangent line at the point P, right? What we do first is actually, well, you can actually see the tangent line here in kind of a purple line. It's tangent to at the curve at P. But how do we get it? The way we get it is we go to a nearby point Q. First of all, we select a point Q. Now, and then we look at this PQ, right? And that's called the secant. And then we slowly bring the Q towards P. And you can see what happens. So when you come here, So when you come here, then the secant is this line, and then you come even closer, come this line, and then you come even closer. Now you can see the secant between the line here is pretty much like the tangent line, right? And when you even become closer, like this line right here, you can actually see that the secant line at this is almost a tangent line. Then of course we get the tangent line. So it's kind of clear that the tangent line, the purple line, is really a limiting situation of the secant line. This is the key to the concept of derivative. The tangent line is a limit. It's a limit. That's why we learn limits. The limit of what? The limit of the secant lines. See, the secant lines limit towards the tangent line. Here too, look at the situation, right? Okay, so they will actually create the tangent line by limiting. Now you can see a nice animation of this right here. So if you want to find the tangent to the line at this point, you can see how it starts. The secants come down. So you start secant as a nearby point, and it actually comes down, and the secant now becomes the tangent. See, nearby point, secant comes, secant, 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 and tangent. Okay, so now let's move on. So now let's try to see whether we can actually calculate the so-called slope of a tangent line. So we learned that in the previous slides that secants actually become the tangent. Then the derivative, remember what you want is the slope of the tangent line. So then if the secant's limit to the tangent, then the slope of the tangent line would be the slope of the secant lines. So if you can find the slope of the secant line and take its limit, then that limit would be the slope of the tangent line, which is the derivative. So let's look at an example. Now here we have taken a very familiar curve, okay? The curve is y equals x squared, the parabola, right? And we want to find the slope of the tangent line. Can you see the tangent line? At what point? At the point 2, x equals 2. So at x equals 2, can you see? And I put x equals 2, come up here. The purple line is a tangent line. So then what should we do? We have to find the slope of the tangent line at 2. The thing to do would be to get the secant at a nearby point. So how do I create this nearby point? What I want is at 2. So what I do is I take the nearby point to be 2 plus. So if this is 2, I go like a little distance h. So this distance is h. If this is 2, then what is this point? Right here. This point will be 2 plus h. So once again 2 and then h, and then this point is 2 plus h. If that point is 2 plus h, then we go up to the curve, and can you see this black line here, not the purple line? Purple line is the limit. Black line is the secant. Can you see that there? Yeah, we have 2. How did we get the 4? Well, the curve is y equals x squared. So we put x equals 2, then you get what? 2 squared, and 2 squared is equal to 4. So this point is x equals 2, y equals 4. And our nearby point is up here. Of course, we know that the x coordinate of the nearby point is 2 plus h. And then the y coordinate of the nearby point is 2 plus h squared. Why? Because y equals x squared. So you plug in x equals 2 plus h, you get 2 plus h squared. So now I want you to concentrate only on these 2 points and not the rest of this kind of a messy situation, right? Sorry for the interruption. So we wanted to now just to recall the purple line is the tangent line whose slope we want to find, and the black line is the secant line between the point we want and the nearby point. And now we want to find the slope of the secant line and take the limit so that we get the slope of the tangent line. So how do you find the slope of the secant line? We use this is a straight line. So to find the slope, we use the formula. Slope is equal to y2 minus y1 divided by x2 minus x1. So what is y2? Y2 is the y coordinate of the second point, which is 2 plus h squared, right? And that's y2. So y2 minus y1. What is y1? Y1 is the y coordinate of the first point, the point that we want, which is 4. So it's y1 is 4 divided by x2, which is the x coordinate of the second point, 2 plus h minus x1, which is the x coordinate of the first point, which is actually 2. So we have y2 minus y1 x2 minus x1. Now if we FOIL this or distribute this, this is a square. So how do you to distribute this? You square the first one, you get 2 squared, which is 4, plus 4h, that's the twice the middle term. So the middle term is 2h, and then twice of that is 4h, because when you expand like a sum like that, you must take the square of the first one, then twice the middle term, and the square of the second one. So square of the first one is 4, twice the middle term is 4h, and the square of the second term is h squared minus 4 divided by the 2 here cancels out and you get h. So now 4 and minus 4 cancels off, and if you go up here, you will see that you get 4h plus h squared, 4h plus h squared over h. But now you can see h and h are common. There's a common h here. So if you cancel the common h, so cancel the h here, cancel the h here, and one of the h's here, then this h is gone. So we have 4 plus, there's one h left here, 4 plus h, and this let is gone. So we have 4 plus h. So now if you look at this 4 plus h, all right, now that then would be what? Let me, there's some unnecessary stuff here, right? Okay, so this 4 plus h is what? This is actually the slope of the secant, all right? So this is the secant line, and we found the slope of the black line. Now tell me, ladies and gentlemen, how do we get the tangent? How do we get the tangent from the secant? If you want to get to the secant and to the tangent from the secant, then the way to do would be, you must bring this point to this point, our original point. Then the secant line becomes a tangent line. In other words, you need to bring this point 2 plus h to 2. And the only way you can do that is to take the limit as this h, this distance is h, this h should become 0. This should come here, means this distance h should limit to 0. So the limit should be h going to 0. So if you want to get the tangent line, the slope of the tangent line, then you must take the limit of this as h tends to 0. So we have the slope of the tangent, which is limit as h tends to 0 of the slope of the secant, which is limit h tends to 0. We found the slope of the secant in the earlier slide, which is 4 plus h. So it's limit h tends to 0 or 4 plus h. Now on Friday's or Thursday's lesson, last Thursday's lesson, we realized when we talked about the limit laws, we showed that if you have a polynomial, if you want to find the limit of a polynomial, you can just plug in. So this is a good polynomial. So if you want to find the limit of that, you just plug in h equals 0. So this becomes 0 and you end up with 4. So the limit of the tangent is 4. So what does that say? We can now say that the derivative of the function x squared, why x squared? Because we started with x squared, that's our function, at the point x equals 2, which is a slope of the tangent as x equals 2, once again let me reiterate, is equal to 4. Where did you get the 4? We got the 4 by taking the limit of the secant, slope of the secant as h tends to 0. Okay, that's all for now, and we'll talk later. Bye.